Hello again. We are now here with the last session we have with tools for exploitation mold by data. And our panelist will showcase how technology supports cities in implementing new things and how they can work on different aspects of technology. I have here my colleague, Miriam Calvo, who is a civil engineer and project manager in Itene, that she will coordinate this session as a moderator. Miriam, the floor is yours. Thank you.
Thank you very much, Elena. I will start sharing. Can you see my screen?
Yes.
Perfect. So welcome everyone to this last session of the SUTS Digital Conference. Hope you have enjoyed along these 2 days of this SUTS Digital Conference, where you can found different findings of the SUTS project related organizational change, capacity building program, innovative financing. And now is the turn to tackle an issue that many local authorities face when they want to implement new sustainable urban mobility measures, that is data collection and exploitation. So this session is called Tools for the Analysis and Exploitation of Mobility Data by Small Medium Cities. And we will see how the opportunities that the transport exploitation can give to the local authorities. We will see innovative measures for transport data collection and methodologies to analyze this data. And also we'll learn about a tool that is able to process the big data in a quicker way. And finally, we will listen the experience of a local authority that have used these innovative tools developed in SUTS project, and they have implemented new sustainable urban mobility measures, integrated passenger and freight transport data. So now is the time to introduce our panelists. We have a multi-diverse expert of panels, from the researchers from academia, from industries, tech companies, and municipalities. Our first panelist will be Miriam Pirra. She is researcher and assistant professor in the Politecnico di Torino. Our second panelist is Fotis Liotopoulos. He is founder and general manager of the company Boeing. The third panelist will be Saba Matrahasi. He is cloud engineer of the Big Data and Artificial Intelligence at Huawei Technologies, Hungary. Our fourth panelist will be Ioannis Krinos, a senior consultant in Kalamaria municipality. Later, before its presentation, we will know more about them. And now I am Miriam Calvo, as Elena introduced me, and I am project manager at Itene. Firstly, we will have a small presentation of each of us, and later we will have a discussion session where you can share with us through the panel your questions, your concerns, and later at the end of the session, we will answer all your questions. Now, before giving the word to our panelists, I will share with you the impact and usability of the data management tools. First, I will go through the challenges that data collection face, the usability of data collection, the impact, and who can get benefit from these tools. In the SUTS project, we have analyzed the cities participating on the project, which are the main issues that the city needs more information regarding transport data. Some of the insights that we found were that it's needed to obtain more information related freight traffic flows, related traffic monitoring, the origin and destination of the vehicles, and related big data analysis. In the SUTS project, our colleagues have developed many tools that we will see in the following during this session. Data they provide, they are related data collection tools that provide the urban traffic data collection. They give us real-time data, but also historical traffic monitoring. They are able to analyze in a quick and easy way big data, and they are also able to differentiate between freight and passenger vehicles, and they give us information about the usability of the transport infrastructure in the city related to parking spots, load and unload parking places, the roads, and so on. So finally, what we try to support with these tools is support local authorities to elaborate sustainable urban mobility measures that integrate the freight and passengers data and support the decision making toward the implementation of sustainable measures by the local authorities. As I said before, with the data collection tools, we provide traffic information and traffic visualization in real-time and historical way, and we are able to simulate new measures that the cities want to implement. For example, if they wish to pedestrianize a street or slow down the speed of a road, they can simulate what will happen with the traffic and then to decide if this measure is well to implement or not. They can also assess the parking spots, for example, the load and unload places. They can know if some places in the city are overused or there are lack of existence in another points, and manage and modify the usage of these parking places. The data collection is also useful in case of street wars or behavior, or if there is a big event in the city, because the traffic can be reorganized in order to avoid congestions and delays to the citizens. And also the assessment of working areas. The working areas are one of the main flows in the cities, the main traffic flows. And in this way, the local authority can assess if in a certain hour is needed more frequency of public transport to go for these working areas, or if it is needed any other infrastructure there. Which is the impact of the traffic and transport data collection? So we get the traffic profiles in the city. We know what are the frequent delivery points. We know the popular routes, and we also know the main flows in the city. With this information, we can develop sustainable urban mobility and sustainable urban logistics plans that provide an improvement in the urban accessibility in the city, and also optimize the distribution of goods. What that means is that we get a reduction of the travel time, the reduction of the pollutant emissions and the energy consumption, increasing the quality of life of the citizens. Who can get benefit from the data collection? Of course, local authorities, as we have seen along these slides, they can implement sustainable urban mobility measures based on the data obtained, but also other stakeholders circulating in the city, like taxi fleets or sharing services fleet companies. They can know where are the hot points where their users, they get more users, and the taxi fleets can avoid the empty running, organizing themselves to pick up the users, and the sharing services can reorganize the vehicles along the city to provide a better service to their users. The logistic company can get benefit from the sustainable measures that the local authority implement in the city, but they also can trace their vehicles from the origin to destination in the city. The IT company get benefit from the data sets collected during the data collection process, but they can use these data sets in order to develop new tools that support the management of the parking spots or the lines in the city. Also, big companies can assess the flows that are produced by their own workers, and they can incentivize the sustainable transport or assess the mobility infrastructure that they have, increasing the parking places or including parking places for bicycles, for example. And that's all from my side. Now is the turn to give the word to our first panelist. She is Miriam Pirra. She is researcher and assistant professor at the Department of the Environmental, Land and Infrastructure Engineering of Politecnico di Torino. She has been actively involved in many Horizon 2020 EU projects. She investigating the travelers' mobility since 2013. Projects like MedPEX, EcoFIBS, SUITS, InSeat EV. She is the author of more than 20 publications and a book chapter, mainly dealing with the application of data mining and machine learning techniques in mode choice and mobility issues. Miriam, the floor is yours.
Okay, thank you very much, Mireia, for kind of introduction. Could you wait? Okay, I'm going to share my screen. Okay. I hope now you can see my presentation. Thank you again very much for your kind presentation. I'm very happy here to be here today to show you the main methodology that we as Politecnico di Torino and partner of the Swiss project we have developed while working in these very productive 4 years of the activities. I think that a good way of addressing the points standing behind the work done is starting from an extraction of the contents of the second edition of the guideline for developing and implementing sustainable urban mobility plan, more in detail the topic guide on sustainable urban logistic planning, because here it is said that local authorities are usually very able to deal with the passenger mobility issues and data, while it is not the same for the urban frame transport data and transport activities and so on. And so most of this data is private, and sometimes the local authorities are not able and doesn't know how to deal with them, which data they need, and which method is needed to analyze this kind of data with the aim of supporting a planning process for sustainable city logistics. I put here also another quick details on some kind of data that are more related with the kind of data that we will analyze in the following. That are the GPS surveys data. They provide useful information about the trip details and the partners and the loading and unloading activities of good vehicles around the city. It is possible to extract information on vehicle trips and runs. As a drawback, sometimes it's not possible to have a high level of details, but in general, they are rather cheaper to be analyzed and to be collected. So what we have done, we have worked in strong cooperation with the city of Turin, that you have already the possibility of know yesterday as a partner of the project, through the data provided by 5T, that is a third party in the project. We started from the data set collecting GPS traces of logistic vehicles fleet, namely delivery van data set, with 360,000 positions recorded in a month. We focus on the month of May 2017. And we are dealing with around 30 vehicles coming from the fleets of various express courier operators. The data contains information about their position of these vehicles, the time of acquisition, the average speed, and the course. Then we were also able to assess another dataset more dealing with the infrastructure and named traffic flows on the city network. In this case, we are considering around 6,000 arcs, let's say roads of Torino and its surrounding, and information available where the average vehicle flows and the travel time necessary to go from the origin and destination of each of these arcs. What was the main goal? The main goal was to try to measure a way in which the congestion could affect different traffic streams or user groups. What we defined, we decided to define, to create a policy relevant KPI that we named the average time lost in congestion. I'm providing here just some quick steps of the methodology that we developed based on the integration of the two different data sources that I presented to you previously. In the first step, we provide a spatial join of the GPS position to the network, the arcs of the network. Then we have been able to compute the travel time necessary to travel along these arcs coming from the derived information of the GPS traces. Then we have been, for us, it has been possible to identify and analyze where the service stops occurs during the month of the investigation. As a further step, we provide an evaluation of the so-called directional free flow travel time to arrive at the final step at the calculation of this KPI. I'm providing here just a couple of slides with some visual results. On the first side, it was possible to identify some information about the network performance. Let's say we try to answer the question, which is the worst arc for the fleets of the vehicle? Let's say the arcs where most of the vehicles lost most of their time due to the congestion. As you see from these two maps, we have found that there are arcs that are differently affected by the congestions, and this is highlighted by different colors, red and purple, let's say. And then it is possible also to focus on different times of the day, looking at what changes during the day. And for example, we see also that obviously in the morning, most of the vehicles are coming to the city center for their deliveries, and during the evening, they are going out while they are finished their work. Another kind of result is the one related on the vehicle, let's say vehicle performance. In this case, the question could be which vehicle is losing most time in the congestion during their delivery operations. And then also in this case, we could see that there are different results. Let's say the vehicles are traveling in different areas of the city according to the deliveries that they have to do. And then also in this case, each vehicle is affected in different way by the congestion in different part of the city. So how can these results and this methodology could be exploited? This innovative data integration method, we think it's rather flexible because it can work also with different kind of data set according to what is available at the city level. And then it could be used to potentially inform a wide range of policy action. We can focus on the most critical arcs for some given travel purposes, in this case, parcel services, but it could be also, for example, commuting. We can investigate which are the most congested areas according to different kinds of user groups. And if, for example, if we have accessibility and availability of data coming from the public transport network, also the most congested line. In general, all these insights could be relevant for different kinds of stakeholders, going from city administration, transport service operation, arriving until specific social groups. Another activities that we have done, always in cooperation with the city of Turin, is tool testing related on the load and load activities in city centers. We have been able to extract more detailed information about the stops according to their duration, the stops done by the vehicles, always coming from the information collected from the GPS dataset. And then through a clustering algorithm and other indicators that we have found to be rather relevant, we have been able to identify specific and critical area in the city centers where a lot of these originates during the months of investigation. And then we think it could be relevant to assess the use of already available unload and load parking spots, going on site with a survey for further detailed investigation. The main goal is now to understand the effectiveness and impacts of delivering operation in specific and key areas in the city. These are some examples of the result that could be obtained. It could be possible to investigate which is the duration of these stops events, when these stops events occur in this specific area according to different hour intervals along the day, and then also the number of packages that have been delivered in the different moment, for example, during the week. Just to sum up, what we have done, we have identified and created this policy relevant KPI that we named the average time lost in congestion, to highlight and to see how the congestion can selectively affect different user group and traffic streams. Then the integration of these two different kind of data as rather innovative. It has been a rather innovative approach that helps in understanding the effectiveness and the impacts of delivery operation in specific key areas of the city. So as I told, it could be possible to investigate if the available unload and load parking spots are currently used, and also to understand which action the local authorities should address to ameliorate the urban freight policies in different locations along the city through on-site activity. I will close my presentation with some, let's say, keywords that I think are rather relevant for also maybe for the discussion. Let's say the main word is data, obviously, because we have them, we need them, and we have a lot of them. So one of the point is how to collect this data, who has to collect, and how they are coming from. I think the analyze is another word that I already say rather relevant for the work that we have done, because it was the main goal, develop an analysis and methodology tool. And then I will give the floor, let's say, to what is coming after. Let's say visualize is also another relevant issue while dealing with data and urban mobility data with the aim of developing some specific mobility and sustainable policies. So I'm closing, and thank you very much for your attention. And thank you, Mireia. I give the word to you. And
thank you very much, Miriam, for this insight. Test in the city of Torino. It's true that collecting data, but without analysis later, it's for nothing, this data collection. So it's very important also to analyze it and be able to use this data later. And now is the turn of our next panelist. He is the Dr. Fotis Liotopoulos, founder and general manager of SUMPs. He received his diploma in computer and informatics engineering from the University of Patras, Greece, and his master and PhD from the Comp SC and ECE department of the University of Wisconsin-Madison in United States. He worked with the Research Academic Computer Technology Institute as senior research engineer, research unit manager, and consultant for several public and private sector projects. He also taught graduate and undergraduate courses in computing networks and computer architecture in public and private universities. Since 1988, Dr. Liotopoulos has managed and participated in several dozens of ICT RTD projects in his areas of expertise. Between 2007 and 2010, he served as an elected General Secretary of the Executive Board of the Hellenic Informatics Union. Dr. Liotopoulos is co-author of more than 60 research publications. He has awarded a Best Paper Award, Vilas and Bodosakis Fellowship, and a number of distinctions and awards for research and academic performance. Currently, Dr. Liotopoulos is the founder, main shareholder, and CTO of SVoin.net, an innovative startup SME in the field of ICT and transport, focusing on GNSS navigation, applications, and systems. Fotis, when you wish.
Thank you, Mireia, for the lengthy introduction. Now that leaves me 5 minutes more to for my presentation. Okay, so I'll start with our vision. Okay, this is first slide is about our vision in the SUS project that we had since the very beginning in supporting local authorities, SUMPs, with data, with respect to data. Just to remind you here that Boeing has been the data coordinator for the SUS project, so we had the responsibility to handle all the issues regarding data. In particular, our vision consists of three phases. Data collection is the first one, data selection, and data visualization. Regarding data collection, there is a need, and this is very obvious in the local authorities, for sustainable data sourcing. Also for accurate and complete data, either in the form of real-time or historical data. In that respect, we have produced a number of tools that I will go into detail later on. You can see the tools that we have developed during the SUS project on this right column. Regarding data selection, we have to be selective about our data searches, especially because there is big data involved when we talk about traffic data. And we also need to standardize and convert between data formats, because there are several of them. Regarding visualization, of course, decision support systems need visualization tools to make decision-making easier. For example, urban traffic monitoring is one such tool, and we have developed tools and platform for this purpose that you will see later on. So a rich tool set that has been developed. It consists of tools that handle both historical mobility data as well as real-time mobility data. We have developed some format converters, for example, and the tool to select among a very large number of GPX files that are typical mobility files, and also a tool that visualizes these files, these data traces. These tools can be useful, for example, for researchers, like Miriam presented earlier, some research results conducted by research from the Politecnico di Torino, and other researchers on mobility traffic, mobility data are also interested in these data sets and these tools. We advocate, we have always been, and we also advocate during the SUS project on crowdsourcing. That is collecting data from different sources, like from citizens, from city vehicles, from logistic vehicles, and combine all of them in order to get the big picture, the traffic of the city. We have developed a platform for this called mypolislive.net, and we did a pilot in Kalamaria, in city in Greece, with data collection through crowdsourcing, where we monitored the entire city's road network, its the mobility, all the characteristics of traffic, the entire road network of Kalamaria using this platform. And finally, we have developed an open data repository where anyone can upload their open data, open traffic data for other people to use them. All these tools, everything is, as you see here in our capacity building toolbox, cbt.susproject.eu. I'll show it later on. So this is just an example of a geoselection tool of GPX traces. GPX traces are mobility traces that someone who's driving, for example, can record their route and upload it somewhere. We have an extensive database of large number, like 500,000 of such files that constitute historical data. several billions of GPS points, location points, all over the world. So using this tool, a user, visitor of the platform can isolate an area and select all the applicable, all the traces that reside in that area. For example, you can see in the next screen that we selected the circular area around the city of Torino, define the radius, for example, and then get all the traces that are either start or end or are within this circle, and visualize the actual trace, the actual route, as you can see here. This was just one of the tools. We have more other tools that I don't have the time right now to go into, but you can visit the capacity building toolbox, as I mentioned earlier, to see all of them. And I will have a slide showing that later on. So the data collection model that we advocate is about crowdsourcing. And what is done according to this data collection model is that data is collected on this right side by different sources like freight data, city vehicle data, citizen data. And after that, they're being processed by some infrastructure, could be cloud infrastructure that the city either owns or has it on the cloud. And from that, it produces results regarding urban mobility, urban traffic management, also combined with logistics, contribution to traffic, and so on. As Boeing is a company developing navigation applications, and we have developed Ultinavi, which is our main product. This is a GPS navigator that also is used for crowdsourcing traffic data. So it's free, it's offered for free, and anybody can use it for offline navigation with maps for the entire world. What you can do with this tool is that you can record your routes and upload them. And also, if you are online, you can directly send real-time traffic data to some source, to either us or to the city. And then the cities can have a picture of the traffic conditions in their city network. We have also adapted it for inside vehicle multimedia console. So any vehicle can just have this application. It's an Android application. Just drive with it, and it keeps sending data and contributes to this crowdsourced data collection. We have developed a platform for urban mobility monitoring. We call it mypolislive.net, which collects all these crowdsourced data. And we have proved the concept in the Kalamaria pilot, the pilot that we did during the SUMPs project, demonstrating that with only a small number of vehicles contributing, 50 vehicles in that case, we were able to depict the traffic conditions in the city of Kalamaria in real time with very good quality, and also to provide historical data as well through the platform. The platform gives various statistics per road segment. I cannot really go into much more detail on this. The platform is a very nice tool, very useful tool for local authorities in order to assist them in their decision making, and also provide them feedback on their policies after the policies have been implemented. In particular, the tool is very useful and has a unique contribution with respect to freight traffic profiling in urban environments, and also to correlate freight traffic with the rest of the traffic of the city. This is very important. This is something unique that other sources like Google, for example, or cellular providers cannot distinguish between these traffic sources, and it's very useful for cities in order to make make policies regarding freight, regarding the loading and unloading zones, and so on. So everything, if you're interested, just visit the single point of entry, which is capacity building toolbox. This was developed by Boeing in the SUITS project to put everything, all SUITS outcomes in a single single shop, let's say single entry. So if you go there, you can see everything, and in particular with respect to data tools, there's a page about all the SUITS tools that are available, that have been developed during the SUITS project and are available for cities, for local authorities. All of our tools, all the outcomes of the SUITS projects are offered for free to every city. And I can expand on this later on. Finally, I would like to just report that we have also developed an open data repository where people can visit and download anything for free without any username, password, login access credentials. And they can also contribute their open data in that platform very easily. It takes about 15-20 minutes to upload your data collection. This is how the visitor access looks like. You can select, you can search for your data, you can select and download for free, and this is how your contributor access looks like. Everybody who's using it to contribute must make sure that the data that they're uploading is anonymized or pseudonymized, so in other words, GDPR compliant. So this is this has also been registered, this open data repository in Referee Data, which is a global pan-European registry of research repositories. Thank you, and I'm available for answering questions next in the discussion.
Thank you very much, Fotis, for your interesting presentation. We have seen many innovative tools for data collection and also to the data repository. That is very interesting. If you have any question, please include them in the chat, and in the discussion session, we will answer all of them. Now is the turn of the next panelist. He is Mr. Sava Matrahasi. Is the product owner and cloud engineer of the Big Data and Artificial Intelligence and Anything as a Service squad of the Open Telecom Cloud in Huawei Technologies, Hungary. He has a long and successful record in the ICT sector as a software engineer focused on big data and artificial intelligence solutions, and in the emergency medicine sector as a paramedic. Sava is also a contractor for Lime Diagnostics as a software development manager for a state-of-the-art medical artificial intelligence solutions. He also worked for Big Data Kurt CO in various positions in the main business units after transferring from Lockdrill, where he worked as a software developer on the Petapylon for traffic management project. Before switching to the ICT sector, Sava was a lead emergency medical technician paramedic at the National Ambulance Service in Hungary. Sava is also the chair of the board of a foundation supporting ambulance services in Hungary. Sava, the floor is yours.
Thank you, Miriam. Let me share my screen. And let's begin. So I would like to begin by firstly introducing the goals and the use cases for the result of our software development project, the state-of-the-art analytical database system, Petapylon for traffic management, designed specifically for traffic management and research and development purposes. Our role inside the project is to provide a powerful data processing and analysis solution for big data use cases, specifically for civilian traffic research and development. Our solution can be used for processing and analysis of any data source using any format, producing big data in real time or in batches. By extending our solution with artificial intelligence and business intelligence tools, PP4TM can also be used for the deep analysis relationship between different data, reporting, and even forecasts. Now let's take a look at our solution's main properties. First, it is able to process data of any structure coming from any data source, as I pointed out before. It has really fast response times. It is relatively easy and cheap to deploy and maintain compared to other commercially available alternatives, and it implements open source software. The system by design is proven to be robust and fault tolerant and is linearly scalable. PP4TM can be easily attached to most AI and BI platforms for your convenience. Our software has been developed to serve the needs of local authorities producing huge amounts of data from various data sources. The deployment is a practice-oriented data center hardware and software ecosystem. We can process a practically unlimited number of data and data formats. By receiving all traffic data generated by a large city, we can still maintain fast query times, and we can support historical analysis with a large and expandable storage capacity. And finally, we can have a number of applications that can rely on the data that we have channeled into PP4TM. Our solution supports redundancy and high availability options, while also maintaining maximum security by utilizing a gateway computer acting as a firewall inside our computer cluster. And by the way, just to mention, our basic configuration setup used in the development consisted of 4-node computer cluster using 1 name node and 3 data nodes. And tests have proven it has a very high efficiency. Finally, a wide choice of business analysis tools can be connected for reporting, data mining, visualization needs, and so on. Now, let's see an imagined use case for PP4TM in an imaginary city. This city uses electromagnetic loops for measuring traffic in the city center that records the date, time, position of the EM loop, and if a vehicle is constantly above it or it has just passed over it. Now you can imagine for that every EM loop in the city, this would generate many data points or rows of data per second. And what else? Inside our city, we also have equipped some of our vehicles, for example, buses, taxis, with GPS sensors that provide the city with information about traffic congestions, providing us with date time, position, and speed records. We also have a vehicle identification system that we can use to measure the types of vehicles passing through the arch, and also to see how much time it takes them to reach point B from point A. All of these data are generating thousands, maybe up to millions of records per minute, and they are channeled into PP4TM for storage and processing. The city traffic control center are thereby provided with visualization and the possibility to display real-time data. Maybe they can also share this with the public. They can also use it to generate automated reports of specific periods that would allow the city to take actions on short, longer, or mid-time. Before choosing PP4TM to work for your city, consider the following benefits. PP4TM can be used to channel any data sources in any format into it in real time or in batches. It can be used to store these data for analysis purposes and access them very quickly. If storage space is exceeded, it can be easily and cheaply expanded in the runtime without interrupting service. The tool can also support high availability options. It can work with a wide range of business intelligence tools to quickly serve your visualization needs. And most important, personnel should already be available in the City Bureau, further reducing the costs running our solutions. And also in the little picture, you can see it is one giant black box containing all the servers. Let's compare prices. When compared to similar commercial solutions for handling big data, we have chosen 3 cloud providers for this example. We can see that while delivering the same performance, our product may be up to 3 times cheaper than alternatives. For example, when compared with other cloud providers' similar solution, we can see that they offer scalability, high availability, and SQL support by default. This is nothing special. When we examine the options for data storage, we can see that PP4TM supports data storage up to the petabyte scale. This would mean that we can serve almost every need for data. We can also clearly see that our solution costs only at least half or even a third of other products in the first year due to the cost of hardware, by the way, and less than 20th a month after the first year. What are the basic usage steps for running PP4TM? Well, these are the following. We create a table in PP4TM that will contain all of our relevant data from the city or local authority. This would mean one huge table, not many smaller ones like in traditional databases. We use PP4TM to convert different data into the common data format. We start to store all of our data in PP4TM, connect our favorite visualization or BI tools to the system. We find correlations in different types and sources of data and make connections using SQL joins and other queries, of course. And finally, we use visualizations and reporting to display them according to the LA's needs. Finally, we can expand our data to real time and use the live visualization options. As pointed out before, the various data sources need to go through runtime conversion first. This process is known as ETL, or extract, transform, and load procedure, and is considered an industry standard methodology in data processing. The result of this process will provide you with the common data format that can be loaded into PP4TM data warehouse and used immediately for reporting, analytics, and data mining. The currently loaded demonstrational dataset includes about 626 million records from S-Boeing's data repository that contains various civilian and freight vehicle routes, GPS traces, and is considered open source data. We have included some visualization features from popular business intelligence tool, Power BI, and just to mention, PP4TM has an average return time of 8 to 24 seconds for non-aggregation queries inside this dataset. We also have access to S-Boeing's Kalamaria pilot data, that is about 500,000 records in total. Also to Machios logistics data, that is about 250,000 records in total. And we also have access to Transport for West Midlands data that contains data about or of bus stops, real-time bus journey times, streaming API as well. There is an option, thanks to S-Boeing, for developing the capacity building toolbox. Now that if you would try to see what PP4TM can do for you, you can visit this website mentioned here where the live demonstration is available and try out our system using the sample dataset. During our tests with other project partners on this dataset of nearly 626 million records, we have achieved average return times of 8 to 24 seconds, meaning an average performance of 30 to 50 million rows per second. In order for these numbers to have more context, Please note that traditional databases like MySQL were intended for and work best with less than 10 million rows and start to struggle with return times above a few million records. For traditional databases, these same queries would probably last from several minutes up to several hours. And that concludes my presentation. Thank you very much for attention. And we are ready for any questions at any time.
Many thanks, Sava, for showing how PPT4TM can process big data and how can we use this data. Now is the turn of our last panelist, Ioannis Krinos. He will show us the experience of a municipality of Kalamaria. He is the freelance consultant of Kalamaria's municipality, responsible for the organizations of scientific support in the execution and completion of the European project suites. He also worked as an assistant supervisor engineer in 2 construction projects of Egnatia motorway for 11 years. The projects were located in Central Macedonia and Western Greece. Egnatia motorway is the Greek part of the European route E90. It runs a total of 670 kilometers. Furthermore, he worked as an assistant site engineer and quantity surveyor of a private construction company at a railway construction project, the project of the railway main line Athens-Thessaloniki. Ioannis obtained a degree in engineering from the Aristotle University of Thessaloniki and 3 Masters of Science. The first master is in Design, Organization and Management of Transportation Systems at Department of the Civil Engineer of Aristotle University of Thessaloniki. The second master in Project Management at Department of Civil Engineering in the same university. And finally, the third is in Environmental Planning Infrastructure at Hellenic Open University. Ioannis, the floor is yours. Ioannis, please, can you switch on your camera?
Yes. Sorry, can you hear me? Yes.
Yes, but we cannot see you.
Why not? It says I cannot start the video. The host has stopped it. Sorry. I cannot open.
Okay, then.
Can I start?
Yes, of course. No.
No.
No, yes.
Okay. So, thank you, Maria, for your comprehensive introduction. I will proceed to my presentation in the view of municipality, how a municipality can handle data. So the tools in this project that Kalamaria, which is the municipality and partner of this project that used during this project was the switch tool myPolisLive.net, which Fotis before mentioned. I will say briefly that it is a real-time transport data platform, combined passenger and freight data, and more it's is a data analysis tool which handles different features. For instance, various statistics per road segment, speed distribution per segment, or stops for freight traffic, etc. This tool fulfills the citizen's possibility for access to information about the traffic conditions that are outside and how the traffic impacts different ways of life, such as safety, equity, the environmental outcomes, which is very important in this case, and also the mobility of people and goods. I will also add to this that this project handles both with passengers and freight data. And that's, I think, differentiates this project from other projects in Europe. The second tool that Kalamaria used in order to handle the mobility data was the online mobility survey using a questionnaire that used according to the update needs of the organization during the European Mobility Week. I can add that Kalamaria's municipality participates in the European Mobility Week since 2013. The overall outcome of all this is that we can implement, integrate new, reliable, innovative passenger transportation and logistics measures in Kalamaria according to all this kind of data. Also, new mobility studies can be conducted, and also we can visualize and handle the future trends according to the prevailing and existing conditions in the society. The tools are recommended for SUMP and SALP. SALP, I can say it's the Sustainable Urban Logistic Plan. Overall, of all this, we can say that we can build with the right use of data, sustainable, equitable, accessible, healthy, and vibrant cities, which I think is the main goal of all this. I can proceed to the measures that Kalamaria can use in the future or already used during this project. Here in the screenshot, we can see that, and I can say that all the data that you see in the screenshots are extracted from the pilot program that accomplished during this project in the Kalamaria pilot. In the map, we can show that in the logistics view of traffic in a certain Kalamaria's region, we can see the stops density of freight vehicles, which are shown with the deep blue spots you can see here. Indicative solution for this and solving this problem will be the installation of new loading and uploading freight parking slots according to the updated data, or the adjustment of new time windows for freight vehicles transport. I can say that as you see in the screenshot, the two blue spots are near retail stores, mini markets, shops at main roads or near the commercial center, which generate big traffic. Another outcome of using the data of mypolislive.net was the new mobility study that conducted in Kalamaria, which lead to effective enforcement of traffic regulations. You can see in the upper screenshot an intersection in an area of Kalamaria near a school on the left side of the screenshot. So we needed to take new road traffic regulations in a four-way intersection at Kalamaria subject Finicas near, as I said, the primary school. The data were extracted from a mypolislive.net platform in order to use a cut site installation. Cut sites are retroreflective safety devices used in road markings in order to use them near the intersection in both four ways. Specifically, we used speed distribution which measured in kilometers per hour in order to measure the device's total length installation in all four ways. Another mobility measure that we implemented during this project was the installation of pedestrian devices for visually impaired people. According to road popularity that is shown on the screenshot, and due to the local mobility conditions and needs, I can say that, as you see in the screenshot, is an area near the main commercial center. And as it's shown, Near is the main Kalamaria pedestrian street. So a lot of pedestrian traffic is generated, especially during weekends. So we need to operate new pedestrian devices fitted on traffic lights for use by people with visual impairments in order to help them to cross safely and reuse this route. So mypolislife.net helped us visualize these traffic conditions and gave us solutions that can impact safety, equity to all people in order to build, of course, equitable and accessible cities from this utilization platform. Another tool that Kalamaria used during this project was the online survey. The survey used a questionnaire to the employees. You can see that this survey dedicated to the employees of the municipality in order to catch and monitor the daily mobility. The sample consisted of 98 people. So we searched the future proposals to improve the sustainable urban mobility. It was interesting that half of them would use a free conventional bicycle from a possible bicycle station that can be implemented in the future, and 1/3 could use an electric scooter in order to commute. So the survey was conducted during the European Mobility Week, and it showed that the pandemic increased the positive answers for people powered mobility, which is safe walking and cycling, and also the future e-mobility. So I can say finally that the data that we are talking about and are used in different cases in Kalamaria region is the king, as we said, that and very essentially this field of search and making new measures for the urban sustainable mobility, and with the smart cities become the buzzword, which is a trendy term used that everyone hears more and more during the last years. We can see that the significance of the mobility data is enormous, and the cities and the municipalities must have the tools in order to maintain their cities viable to the people and make it more helpful and viable to their citizens. The mobility is an area that produces enormous data sets, and the municipalities must have the available tools in order to handle all this kind of data. Thank you. Mariah, I can give you the floor. Thank you very much.
Thank you very much, Yanis, for showing us how the transport data collection can support the implementation of new urban mobility measures in the cities. Now is the time for the discussion session, sorry. So I ask all the speakers to switch on your cameras. And the audience, if you have any question, now is the time to answer it. If you have any comment or concern, you can share it with us. Now we have some questions from the audience. So, for example, the first one is, along the session, you have talked a lot about data collection tools and methods, but how do you manage the privacy of the data collected or analyzed? Maybe.
I guess this is for me, because I've talked about a lot of data collection. So people are becoming suspicious when you tell them that I'm going to get your location, your mobility information. They get suspicious that they're being followed, and to a certain degree, they're right, because you can people and even big companies can exploit this information for different purposes. So what Boeing has done in this respect is, first of all, it has established its security policy as a company, because it handles data. And with respect to GDPR, now there are certain requirements that the company has to fulfill. For example, we have established a data protection impact assessment, which basically says that we are, let me put it this way, we're okay to handle data. In particular, the type of data that we're handling, like mobility, traffic, and so on. On the other hand, we have also established data processing agreements with companies that we collaborate with, and who are, as they're called, data processors or data controllers. We're data processors ourselves because we do process data, but we're also data controllers because we have other people like our cloud infrastructure service provider who provides services to us and who is our data processor. So GDPR has made that a complex situation, but this is in favor of privacy. The other thing that I can say is that all data collections that we do, or our platforms, support end-to-end strong security, strong encryption of data communications. So nobody can eavesdrop the data transmission in between. The data is stored after being processed. Initially, they're stored anonymized or pseudonymized. And also something that also needs to be explained here, showing that it's tricky to anonymize data and make it GDPR compliant. For example, let's say we are recording people's mobility, car's location monitored, for example, 24 hours a day. During the night hours, this car is parked, most likely near the person's individual's home. So in this way, someone can correlate this fact and find out where the location of this person's home is. And if there's is a block of flats, this guy lives in a block of flats, then perhaps it's not straightforward to pinpoint who this person is. But if he or she lives in an isolated place, then by monitoring its nighttime location, then you can find where this person lives and eventually identify this person. This is not allowed according to GDPR. So we would try to anonymize our traces, taking into account this fact. For example, all the traces that we have, and we have uploaded some traces in our open data repository, like that from the Kalamaria pilot, for example, or from the Thessaloniki pilot, another pilot we did. What we did is we isolated only the motion of the vehicle, not the part of the vehicle's trace that the vehicle was idle, parked somewhere. And also we chopped off the leading and the trailing part of the trace, like a couple of minutes at the start of the vehicle's motion, and a couple of minutes before the end of its motion. In this way, you don't get a clue where the vehicle started from and where it ends, where it gets parked. So this is just to give you an indication of what kind of processor needs to be done in order to ensure privacy, and what we have been doing in this respect. And this is not always an easy task. Sometimes, for example, when we anonymized the Kalamaria trace, it took a lot of processing time and effort. So this is something tricky. It needs to be done. Boeing has been doing that, and that's why we have proven several times that we respect people's privacy and we are GDPR compliant.
Mm-hmm. I think Fotis, thank you for your answer. It is really complete. And I think that you have answered also another question that we had, that is how you guarantee the protection of citizens' personal data related to tracking the movements. So I think that you have answered also this question too in your answer. Saba, Miriam, do you have any other comments related to the privacy of the data collected or the data analyzed?
I only have one comment from our side. PP40M uses, as it is a state-of-the-art technology, it of course uses maximum security to secure the data that has been put inside that system. That's all I wanted to say, really.
Yeah, just add a quick, let's say, point of view from the part of the analysis of the data, because commonly when you're dealing with data collected, then you join contribution coming from different kind of data and different kind of users. So in general, you have a joining of all the information. So you are losing the single information of the single user. So in some way, this could be seen as sort of protection of the privacy of the people who is providing the data. So just a quick comment on the side of the, let's say, the data analysis.
Mm-hmm. So that's clear that all the data collected is anonymized, and everything is made from the secure point of view in order to give privacy to the people participating in the data collection. We have another question. Maybe Ioannis, this is for you. You have tested the mypolislife.net tool developed by SUMPs, and the question is, to use these tools developed in SUTs, should a city authority employ a specialized experts?
I think yes, because in order to assess all this, as I said, enormous amount of data, collection of data sets, an expert is needed to how to use all this type of data. The reason is that, and the main concept is that, how to use it. If we get back all the privacy issues and etc. for the data, in order to use them correctly, reliable and efficiently, I think a transportation engineer or something similar is needed to assess, evaluate, and use the data and make them real. You understand? A data on its own, a data set on its own, it doesn't mean nothing if it is not used, it's not utilized. So an expert is needed in order to take different kind of measures. It's a complex situation, because mobility captures a lot of things, okay, inside on its own. So I think yes, an expert is needed.
Mm-hmm.
Can I also add to that? There are different kinds of experts that are can be involved here. For example, it can be an IT person. So sometimes, most of the times, actually, small, medium cities have capable IT personnel, support personnel that can do all these technical things, like install our systems, run them, collect the data, and but most of the times they're so busy that the city needs to get additional personnel in order to do the extra things that are involved. So, and this is only one type of expertise. Other expertise, for example, is analysts, data analysts. The analysis of data requires certain skills, and also the implementation of the results of the recommendation of policies requires also another skill. For example, traffic engineers. Yanis knows what I'm talking about because he's one. So it's not only IT skills, but also traffic people, traffic management people who are involved. So it's a multidisciplinary involvement that is required here.
Mm-hmm. So we need different profiles. Let's see, IT profiles, traffic manager profiles. Sava, Miriam, do you want to add something?
Yeah, I think that from the experience that also we had during the project, it is, I think, important and relevant to have a good cooperation between different actors, in the sense that also if you're dealing with small, medium local authorities, small, medium cities, it's not easy to have all the people having all this kind of knowledge and very technical knowledge. So on my point of view, I think that it is very important to try to understand which could be which kind of support could be needed, and who can be addressed by the local authorities when they are searching for this kind of support. I think the cooperation is very important, also because maybe it's not easy to, as I told, have the people inside that are dealing with some specific and technical topics. I also think that the work done during the project with the, let's say, the technical contribution, and also the capacity building toolbox itself, and the material that has been provided could start giving a direction, some first steps towards this direction. Then the cooperation with some external support is, I think it's anyway important.
Mm-hmm. Yes, we took note that we need this external cooperation. As Miriam said, the local authority can't have all the different profiles that it's needed. And Sava, what is your point related to the PP40M tool? Or
thank you for asking. I would mostly agree with Fotis because he's made such a good point about the personnel needed.
Could you get closer to the micro, because it's hard to...
It's distorted. Is it better now?
Yeah.
Sorry. So I would agree with Fotis on his point, because he has made a point that most of the personnel or experts required to run our system, like system administrators for IT services, and transport engineers or traffic engineers, and also data analysts or business analysts, should be already available in any local authority. And this was one point that we kept in mind, actually, when we try to design our system, so that the local authorities, the end users, won't have to employ new people, new experts. Yes.
Mm-hmm. So all of you are agreed that these new experts will be needed in the future for this kind of analysis. And now we have seen along the session different tools, and we have seen also the Kalamaria experience using the transport data collection. What do you recommend to local authorities that want to benefit from data collection and analysis tools? How should they, which is the starting point for a local authority that wants to start to using this kind of tools?
Should I go ahead?
Please.
Okay, as I said, our capacity building toolbox is one-stop shop, let's say, for the SUMPs project. So it contains all the conclusions, all the outcomes. So this is a very good starting point for every city. Just visit it, start browsing whatever is what you're looking for. If it's tools, there's a separate section about tools that you can browse. We have all the tools available there for free. Again, and that also responds to one of the questions, I think, in the chat. The tools are, all the tools developed in the SUMPs project are offered for free to all the cities, whether participating in the SUMPs project or not. So this is because it's a European project. We developed it during the project. That includes our platform, mypolislive.net. We can offer any assistance for the city to use the platform to begin with, and if more extensive assistance is necessary, then we can perhaps arrange a contract. We're also available for more long-term relationships with any city that is interested in further, using our tools. So yeah, I would recommend just start getting familiarized with the tools, going to the capacity building toolbox, and then if you have any questions, just feel free to ask.
Mm-hmm. Ioannis, which was, for example, the Kalamaria example, what was the starting point for Kalamaria?
Yes, I suggest that and I agree with Fotis that switch capacity tools contains all the material that any municipality can handle in order to have a new, let's say, new insight in the urban mobility, sustainable mobility, but I think the starting point is to have a strategic plan. What each municipality, what is going to what are the aim of each municipality in terms of sustainable mobility. So the tools that are inside the switch capacity toolbox, as my Polish live in the first point, is an essential tool that someone can start with. Mm-hmm. So each municipality can install GPS traces, GPS tracks, in order to have this kind of data. Mm-hmm. So there's a preparation in order to use this tool, as Kalamaria did in the pilot program of Switch project. Okay. So a strategic plan in order to see what each municipality, what is needed in order to reach the target. Mm-hmm. In improving sustainable mobility.
Mm-hmm. So the first step is to have a strategy, to know what is the way in the city that we want to improve, what we want to improve in the city, and then go for this data and then try to get the data to implement new measures according to it.
If I can,
you want to say something?
Yeah, if I can add some word, I think that this point just gives some answer to the question of my first slide in the presentation, that was which method and which data. I think that the work done during the project, also in cooperation and coordination with, for example, the cited guideline from LTIS, can give a great insights and great support on this when the first point is where do I have to start? What do I have to do first? And so I think, as also Ioannis is saying, that we have did a good work in this way, and it's fine, I think.
Yeah. We have another question related to this, what we are discussing. So maybe you can quickly answer it. Is how can local authorities choose the suitable data analysis tool according to their needs?
Yeah, I can pick it up. Well, data analysis is something you cannot really define it in a unique way. It depends on what the problem is, and depending on the problem that you have to solve, then you have to follow some certain methodology in order to solve it. And that involves getting data, evaluate your data sets, come up with some results. So it's not something that you can give a very specific guideline on how to do it and what to do. Depends on what you want to do. So first of all, you have to define a strategy, know what your problem is, define a strategy how to attack it, and then you will find out what the required analysis is in order to solve the problem. For that purpose, what you also need to know is what are the available tools for the solution of the problem. So the analysis also contains this part, because if you don't know what is available in terms of tools, in terms of solutions, then your analysis cannot give you the right guidelines about what to do. So you need to proceed in parallel directions. One direction would be to know what tools are available to you, and that's why we have developed all this capacity building toolbox and all these tools. So someone, an IT person or a traffic specialist, for example, someone in the city, has to know that these tools are available. And then when the problem arises and they need to solve it, provide an analysis such that it includes, in the methodology of getting to the solution, it includes also the right tools for that purpose. So it's something that you need to, to attack it in parallel directions. And there is no single analysis methodology for that. It depends on the problem.
I can add to that, sorry.
Yeah.
I can add that, as I said before, data is being lightfully called the king. So it is essential for decision making and taking better solutions. So in order to achieve this target, this aim, this goal, a tool is needed in order to visualize the current situation or historic situation of its region. I think without a tool that visualizes the situation outside, in the streets, nobody can take good decisions or fair decisions for the citizens and the people living there, the tourists, etc. So the tool helps the decision makers in order to, for instance, take measures for urgent cases. There are urgent cases, for instance, the stops that generate heavy traffic, the congested areas. It depends on how you can imagine all this, how you can inspire the traffic outside. But urgent cases, I think, is the starting point in order to use these tools.
Okay, good point to start the urgent cases.
And also, let me just add to this one. The need for data is continuous, and the reason for this is because you not just because you always have problems to solve, but sometimes you provide solutions to the problems, and then you need to evaluate your solutions. And the evaluation of the solution is continuous because it's a dynamic situation, the dynamic conditions. City traffic, for example, is a multivariant problem with many things affecting. For example, works are happening, and the whole situation changes. The whole traffic image of the city changes, and you need to have a continuous evaluation of this. That's why we emphasize on the need of getting up-to-date, updated, and real-time data as good as possible. So it's a continuous process. Cities need to have updated data at all times.
We are getting closer to the end. We have only 2 minutes left, so I will ask each of you quickly in one sentence to say to our audience what they should take away from this session. Very quick, just one sentence each of you.
Can I say data? No, what was data? Visualize, collect, and analyze. It's. I'm allowed to say it. Very quick.
Yes, very quick. You are allowed.
For me, use data in order to have more viable and healthy and sustainable cities.
Should I go ahead or close the final sentence? No, well. For Boeing, it's just only one word. It's crowdsourcing. We have been advocating crowdsourcing and the need for people to contribute. If people contribute, then we have a sustainable means of data collection, The cities can benefit from that. Everybody can benefit from that. So if the city authorities provide incentives for people to contribute, to use free applications, to share their location without fear of their privacy, without having privacy concerns and so on, then they would have a great way of getting data, updated data, and have all the data they need for the decision making. So we keep advocating crowdsourcing.
And Sava, very quick.
Very quickly, cities, don't be afraid to use your data to work for you. That would be all.
Thank you very much for you, speakers, expert of panelists. Thank you for this interesting session, and hope the audience had enjoyed it and can get benefit from this session that you presented in data collection and exploitation.
And thank you, Mireia, for coordinating this so well.
Thank you very much to you all, and to you, Mireia. See you. Have a nice day.
Thank you all
Have a nice
for
day.
such an interesting session.